Okay, here we go. Hi. So last time you guys probably saw a video about Masonetris, this crazy idea of having OpenSees play Tetris and and that way to teach an AI to how to build masonry, basically how to make an AI gain expert knowledge by using simulation. That was a fun paper we reviewed the last time. If you haven't seen the video, you can find it in my channel. And from that, I did a little GPTing to see if we could program the thing, to program actually a video game where Tetris is basically implemented, not in the classical sense, but in the way that instead of, you know, when you complete a line, you delete that line. No, this uses OpenSees to run a stress analysis and give you score based on the factor of safety. That was a fun idea, I thought, for a game, or at least an exercise in some OpenSeesing. So I went over to my friend Claude. Let me show you. And I uploaded the paper just to give it some context, and uh, and then I told him to build a Py game, basically a Python framework for building games, and with some indications, but not it was not a huge prompt. It wasn't structured in any way, and good old Claude gave me some stuff back. So what it gave me, I'm impressed by Claude many times in this such case. So here's a little Tetris implementation, and looks fun. You can see that the colors, it's being colored by stress. So you can see here, green equals low stress, red equals high stress. We'll take a look at that in a while. You can see the colors getting updated, and you can see a safety factor computation of some sort. Now this is pretty wrong. Like, this structure over here should not be stable at all. So I'm adding, yeah, those colors are off. So something feels off about this. So let's take a look at what Claude did, and let's because basically it's AI slop, and slop is okay if you know how to deslopify the slop. So let's try that. I'm gonna close this window. The game ends, and you get a score 53 based on this safety factor. I wonder if let's try it one more time just to do something better. We got 53 with a safety factor of, I forgot how much, but let's try something. I'll be quick about it, just to get a feel. Now these elements are being stuck together. The structure down here is fixed. These are all mapped to brick elements, which are used to compute the safety factor. So let's try to get that over there. Let's get another score. Should this be like, this should relieve a little bit of the stress. So if I place this block over here, nope, not at all. Oops, I'm about to die. I am about to die. So let's just die. Structure collapse, final score 38 with a lower factor of safety. I think it was about 4 the previous run. Okay, so that's cool. That's cool. Um, so let's close Claude for the meanwhile and take a look at Masonetris, the game code. I'll get rid of that little sidebar over there. We don't need that. You can see on the terminal over here that we're getting basically warnings from finite element from OpenSees. These warnings are probably because the constraints, right? So it's saying that the constraints are basically redundant. So you're adding a constraint to an already constrained node. That's just a warning, so it won't the analysis will not fail. Um, and then it says FEA error, C standard out. So I wonder if that means, oh, I wonder what it means. I haven't seen this code too much. Um, so here there's a little data class that you have the properties of uh, of the structure of the structural components. We might want to tweak these so that it's a bit harder. What I'd like to do is I'd like to see the tower deform as you go along. I want to get there, but first let's fix whatever's going wrong with the analysis. So this actually has two modes. If OpenSees is not available, it runs a demo analysis, which is basically trash. And then if otherwise, we run the OpenSees analysis. Okay, so that looks good. That looks good. And then here's the core, the OpenSees core. So you start a model with three dimensions and 3 degrees of freedom per node. You'd need that for a brick-based analysis. I don't think it's doing anything with the mortar. So, okay, so you define the two materials. One is for the stone and another one is for the mortar. That looks fine. And then create nodes for each filled cell. So there's a board. Input to this function is basically the board, which is an ND array, right? And it outputs a tuple and an ND array. The output of this function would be the minimum safety factor and the stress field that it needs to color. Finishing with a wipe, good old wipe at the end. The double wipe at the beginning and at the end. Let's just not miss an opportunity to wipe stuff. Okay, so the board class, which I haven't seen at all, but it tells you basically which cells are filled. And based on that, we add nodes at each coordinates. The coordinates are auto-computed from the grid size. And then cell nodes, we map the cell nodes. I guess this is mapping the coordinate. Yeah, the coordinate tuple to figure out where the cell nodes are. And then for each one of these filled cells, we add a standard brick element with a new ID. The ID is basically irrelevant, linearly incremented. And then the cell nodes are these over here, whatever it figured out it has to. I wonder if these are correctly ordered. Anyway, material number we're using is 1, and this is why we define two materials, but we're only using 1. I don't see any other this 2 material being used anywhere else. So the mortar is not being used. I would like it to stick the different bricks together using a 0 length element to like pretend like we have a little mortar there, and that can fail on its own. Anyway, hello to my concurrent viewer. And then what's going on here? We are applying top pressure. So the way this was set up in the paper is that only the top part of whatever you're building gets loaded. This is something I want to fix. This is something I will fix. But first, let's finish taking a look at this code. Would it be interesting for me to share this code on a GitHub, or is it just slop? I don't know. Maybe it's interesting for you guys. Anyway, and once we're done with the analysis, which we're using pretty standard options over here, we retrieve the stress field. And then we compute a minimum safety factor. So the stress field, we iterate over the filled cells, and we're gonna use the element ID starting from 1 to get the stress. Now the stress is a vector with the stress components. And then we get from that the sigma max. So this is a first error. We don't want the maximum sigma. We want, no, this is all wrong. We want to compute this as they did in the paper. Now, good old Claude gave me an alternative to this. There was, for some reason, in the original implementation, let's go back to Claude for a second. What did it give me? In the project, no, not projects. I want to go to my Pygame. In the Pygame, what I got down from this was, where can I see the assets? Okay, so this one, FEA engine. I got one that's called a FEA engine, and that's at the beginning. I thought that's where OpenSees stuff is. It makes sense, modularize. But then I saw that indeed this was not being used. So I don't have that file here in this directory. It's just a masontrist.py. But this one was interesting. What if I download this? Can I download that? Or can I take a look? Fail to download. I'll take a look at advanced FEA with a proper OpenSees Spy implementation. So let's get this. This one had some interesting stuff, and I thought this one was the one that was being used. So I'm just gonna copy that. Let's shove plot to a different desktop over there. It went to number 5, and over here in masontrist land. Oops. Let's add a new file. So actually over here, and let's call it fea.py. Open it and paste what we got from plot. Here we go. Now I want to steal ideas from this. I remember this had a better implementation, but this is not being called at the moment. From what do you mean write partial file? There we go. So here, one of the things that I saw is that there was several implementations, and one of them was the eigenvalue analysis. Let's see here. Simplify, compute principal stress. So this one takes an ND and gets you the principal stresses. So I'm going to steal this function and use it. So yank it out. And I am just going to add it to wherever the FEA engine is here. Here we go. Run OpenSees analysis. And maybe down here, somewhere, paste it. Compute principal stresses. That should be fine. So instead of over here using the maximum value, which doesn't make sense, let's go in. Let's go in here and comment this out, this little line out, and we will get the principal stresses. So this function over here returns the one I just added. It returns 3 numbers. So we'll just call those sigma 1, sigma 2, and sigma 3. Oh, where am I lost myself. OpenSees analysis. We're in the stress loop at the end here, the post-processing step. So let's just go in here and just call it S1, S2, and S3, and let that be the return from self.compute principal stresses, and we'll call that with stress. And the stress field, I wonder, that's what it gets colored by. So we don't want to use that directly. We might want to use the local SF. So I'll just I'll do the following. I'll delete that and go down here and maybe paste that line back. And instead of coloring by the stress, I'll color by the local safety factor, like so. But first we have to compute that safety factor. Right now it's using stone compressive sigma max. So let's do something simple. Let's do stone, let's say W, and we'll go with stone tensile. So tensile stress over S1. S1 should be our principal maximum. Okay, let's verify that assumption. Let's store there. So we are computing eigenvalues and sort eigenvalues in descending order. So sigma 1 should be the largest one. Perfect. So that means that's S1. We're going to use that as our SF, and we run masontrist with this. Masontrist. Let's see what happens. So now the color should be proportional to whatever the tensile is. Safety factor, we see it's 10. we're not generating any tensile, but there we're as our cantilever starts going, we should see the safety factor go down. Now it's still, I still don't like it. For some reason, it's not working the way I want it to work, because basically the worst place for the stress should be where we have maximum flexural response. So it's not exactly, this is not working out. What if we, minimum safety factor is all of that. Let's take a look. What happens if I print out, go to the end of that line, go into insert mode, and just print out the local SF, like so, and let's give it a good old indentation over there, just to see what the type of numbers we're getting out of this. Oop, there we go. I'm not seeing anything come out. I am not seeing anything. FEA error. Let's look into that FEA error, because it looks like it might be a problem. FEA error. Look like that's okay. Run OpenSees analysis. I'm getting an FEA error, and then I run the demo analysis. Not good news. So I wonder what. Let's just delve into that first. Why is this failing? Why is the failure occurring? Let's go to run OpenSees demo, run OpenSees, this one. Now, I still need to learn how to move around NeoVim fast. Anyway, when I was running this, so I'm not getting to this part because this is not printing. So as soon as I place something, I get an FEA error, and I wonder if this is what bringing up the error, the failure to add the SP to the domain. I don't think so, because that should be just a warning. That should be just a warning. But that's happening here in the fixities. So let's just let's print something, good old school debuggage. Print over here loading, because the loading phase comes after that. So just let's make sure that, yeah, we're not getting to that point. We're not getting to that point. Okay. Let's add another comment over here. I'll go for fixing, because that's what's going on over there. So we should see, oops, fixing. So I guess that warning is where I'm seeing the fixing here. I guess that warning is where the problem is. It doesn't like that this. Okay, so let's do something else here. Node map. So instead of doing this, because it's not liking that we're adding more than one node to the domain, I'm going to do something different. I'm going to say, let's create a dictionary where nodes to be fixed should be a dictionary. And instead of going like this over here, I need to learn how to move around in NeoVim. And I'm still using kind of my intuition that comes from my good old Sublime text days. So instead of doing that, I'm gonna use that dictionary. The good thing about the dictionary is that it's basically a set, a unique set. So I'll just go and say nodes to be fixed like this, and add the key called node map forward. Actually, I could have this be a unique set, but okay, let's just be sloppy for a while, and we'll give it that tuple. We don't actually need that value. So for node key in nodes to be fixed, let's go here and go ops.fix node key and 1 1 1. That way we're just doing it once. Mise en prise, code not defined. Okay, if error code not defined, where's this coming from? Okay, code, no, this, you guys didn't tell me. I messed up that thing, okay. And the thing is, this is running inside a try catch. So the thing about the try catch is that it's not really going to tell me what the error was that where this freaked out. So I'm gonna go all in, man. I'm never gonna call that demo. I'm never gonna call that demo. I'm gonna go in the game board and here the renderer. Wow, I haven't seen a lot of this code. So for example, run OpenSees. Yeah, here's what I want. Let's just FEA error. Let's just comment this out. Let's comment this out. To block comment in Vim, I hear go like this and GC. Yeah, that's what I'm talking about. Block comments. So self dot run OpenSees analysis, and let's just give it the board. And actually, let's this should be return. So I'm just disabling all of this stuff, and I want to see that error. I want to see that error that we're getting. So what happens now? What's up now, Mason Tris? Aha! Look at that safety factor. It's running. It is running. That safety factor is so low. It's just basically always dead. Okay, so we've made some progress. Let's start again. Let's do a little. So this shouldn't have a low safety factor, but it does. But it does have a low safety factor. How about this one? It's too low. Too low to just base it off the tensile stress. Now, if I raise safety factor is, but I'm not seeing the prints of the safety factor. It's fixing loading, that should be, let's do a search for loading. That's the comment. So this is working, but I'm not seeing these prints over here. I am not seeing these prints. Not at all. Not in the slightest. If stress. Okay, so this Eller response call, is that correct? Is this the way you do it? Stresses, isn't it stresses? Because this is also in a try except, so I'm not getting anything out of this. It's not going in here. Something is going on before. So let's remove the try except. Actually, BB this and go back here. My new Vim is just bad. It's just bad. This will just give me an OpenSees error if there's something wrong. So let's try running this. Fixing loading. We should be able to get the stress out. Let's just print the stress. Let's print the stress like so. Stress like this. Save that. Run good old Mason Tris. We should see. Aha, 0. Everything is 0. Why is everything 0? Nothing's getting loaded. This is a problem. So what's what's happening here? No stress anywhere. No stress, man, no stress. That's probably because of the loading. The loading is going on in this way, so nothing is getting loaded because look at this. This is just wrong. Time series, the pattern. Okay, this should be defined before. So let's first try a simple fix. Let's do 3D to chop that off, and let's just paste that over here. What that did is it made the time series and the pattern be defined before I start adding loading. Otherwise, the loads don't have a load pattern to go to. So that would explain a zero stress state of stress. Okay. The next idea would be to see if this is actually getting called. So as before, pressure force, like, is this being called at all? I don't know. The other way I can do this, is add per element loads. I think that's a better idea. We don't need all this junk. So let's go into, can I do GC from here? Oh, I can comment like in the old school that way. That's good. That is très good. Très good. Très good. Très good. So what I am gonna do is add forces based on the material density. That would be nice. So let's go into the OpenSees document. Oops. In the OpenSees documentation. But I do need a new browser window, so let's get everything out. OpenSees Pi. Let's go standard brick. And over here, so after the mat tag, we have the 3 body forces. Let's finish up with this. So the 3 body forces, I should come up with a little list like this. It's going to be 0 in the x direction, 0 in the y direction, and I'm going to go for negative density, something called density, stone density, this one, times gravity. I don't even know what units we're in. What units are we in? Does the top say anything about units? Nothing at all, right? Ah, megapascals. Gravity. That's gravity. That's what I need. Okay. Okay. Let's go back to where I was before. How can I add like a bookmark? OpenSees I FEA engine. Stability penalty. What is this? Ah, that's the demo analysis. Okay. That didn't make any sense. So stone density, and let's multiply that by gravitas, like so. There we go. Am I getting stress? Ah, its stone density is not defined because it should be self.config. Okay, this is good. This is good. So self.config.stone density, like so, and self.config.gravity store. And let's run Masonries. We're still not getting any stress out of this. And those colors are just fake, man. Those are just fake. Doesn't make any sense at all. I wonder if we're not getting stress. Like at this point, I didn't load them. That's not enough. Silly old me. So that way I unpack this list into the final arguments of the element call. Are we getting stressed now? Are we getting stressed? We're getting stressed. We are getting stressed now. I don't see the safety factor improving, so that's an issue, but we'll trace it to something. Let's see here. Fixing. Let's get rid of that stress over here. I'll just comment this line. Can I go into maybe like this and insert, like that. So bad. Is this print going on? Let's take a look. Let's take a look at that print statement. Yeah, no, it's not going into the try. So something's happening here. If stress, except pass. So nothing is happening here. So I'm just gonna remove and because I am a dummy and I don't know how to do stuff in new Vim yet, I'm just gonna go for, so that I don't mess up my indentation, I'll just go if true. And this is painful. I'm sorry you guys have to watch this if you're watching. If you're still watching about all of this mess, you might want to give it a like. I don't know. Oh, somebody is getting something out of this. Okay, so here, sigma max is not defined. Good. That's the problem. I am a dummy. So if sigma max, let's change that by S1. If S1 is greater than 0, local safety factor is going to be stone tensile. There should be a positive eigenvalue. There should be one. Oh, yeah. Oh, this is looking good. Oh, take a look at that. So now if the safety factor is below a given threshold, stuff just dies. This is good. This is very good. My safety factor is 0.52. So this is getting closer to the kind of stuff we want to do. Maybe those values are too low, but it doesn't matter. Tensile stress over S1, that should be greater than, this is so fun. This is so much fun. Let's just quickly give it, so these are small values. I will raise the tensile strength by a little bit, maybe by threefold, I think. So compressive, 35 megapascals. Let's go for 35, 70, 100, something like that. Just for now. Just for now. Just so we can play a little bit more. We should be able to play a little more. So there goes the L. Super low safety factor. How do I get that safety factor up? How about if I place it over here? Structure collapsed. Safety factor 0.96. So let's take a look at the exit condition. When does a structure collapse? This is so much fun. Structure collapsed like this. If draw game over. Okay, so there's a little function called draw game over. If the game state is game over, you draw the game over. But when is the game state game over? Let's take a look at game over. Game over, man. It's game over for you. Over here, can place. Check if spawn position is blocked. Okay. Calculate the score. Game over. If no. If safety factor is less than 1 and self dot pieces placed is greater than 1, then okay, so this is where the game logic is going on. I should probably here, by the second piece, if my safety factor is less than 1, this is basically gonna die. And after placing one piece, these elements, they do have a safety factor less than 1, at least for the tensile part. At least for the tensile part. I want to see this. What if the safety factor can't be less than 0? Let's give it a really low safety factor, because the other idea would be to just keep bumping up. I guess that's better. The compressive I was changing the mortar. I should be doing the stone, right? That's the one I'm using. Stone, compassive, safety factor. That next. Stone. Where am I using stone? Compressive. Stone tensile. No, I am using the stone tensile. Okay, let's go up and take a look at the. No, I switched the wrong one. So this one, the tensile should be at least 3 times larger. Let's make it 10 times larger. Let's go for a whopping 28 megapascals. Megapascals. I should be able to survive a little bit more in this game. Like this. Safety factor is 2. Let's add this one here. Okay, that's fine. I'm gonna try to support that overhang from there with this little bar, and that should improve my safety factor. Look at that! Safety factor 1. I am the boss. And this is good. Okay. Here we go. This is gameplay. You can see where the worst spots are. If I put this here, it will reinforce my safety factors. Oh man, look at this. Let's go over here. Okay, good old Tetris rules. I really want to place a bar. Man, is this gonna... I'm dying. This is amazing. Structure died just by placing that. Okay, this is actually nicer gameplay. Now my safety factor, and it died at the bottom there. That went below 1. That's fun. That's fun. This is getting there. So stuff. What I want to see next is let's see real quick if we can get this to the form slightly, or I don't know. There should be the renderer. So let's go to the renderer. Renderer. Maybe we can ask rectangle pipe. I don't know how to draw board, draw header. Okay, so there's a draw board, and these are the this is the code to get the board to draw itself. Mason trees game. Nah, I'm gonna leave this, I guess, for the next edition, because this is gonna take a while for me to figure this one out. Draw a line, draw a board, but it knows how to build Tetris from nothing, basically. So it's pretty amazing what you can get done with a little bit of IA and some OpenSees. I think I'm done for today. Yeah. So would this be fun to have online for you guys? Uh, what things should I do? So some ideas I have is I want the form shape to be there. I would love to refine, so maybe split the blocks into more than one block, so that way we can have a finer detail of the stress field. That would make it a bit more challenging, I think, because of stress concentrations. Would nonlinear analysis make any sense? Like this is fast enough with the linear analysis that that you can run in real time. But if you start iterating and it fails, then it's a whole other level of complexity there. Might make sense. I do want the mortar to be modeled in separately. Yeah, these are a couple of things that I want, and maybe to consider more than one component of stress, so that it might fail by crushing. Unlikely. More likely that it's tension, like we have it right now. But different values for the mortar and for the stone would be a good idea. What else? What else can we do? If you made it all this far, just give it a good old like. I get my food from that. Until next time.